For today's homework, we'll be doing the worksheet, the transformation worksheet. That's all about transforming absolute value graphs. I'm going to start with problem number 3. The directions for this problem says, without using your graphing calculator, describe the transformations to the parent function to create the following functions. For the function A, tell whether the graph is reflected over the x-axis. B, whether it is a vertical stretch or shrink. C, whether it moves left or right. D, whether it moves up or down. And E, identify the vertex H, K. So let's think about what we know about absolute value graphs. And I'm going to write down the general equation that we have for an absolute value equation. So we have y equals A times the absolute value of x minus h plus k. In the general equation for the absolute values, a, h, and k tell me a little bit about how the graph is moving around the coordinate plane. A will tell me whether it has reflected over the x-axis. If A is negative, that means it has been reflected over the x-axis. A can also tell me if I have a vertical stretch or shrink. H will tell me whether it moves left or right. And K will tell me if it moves up or down. My vertex is always H, K. So let's take a look at the function that we're given here. It's y equals 2 times the absolute value of x plus 3. And let's just go ahead and go in order of our directions. So part A says, tell whether the graph is reflected over the x-axis. So for this part, I need to look at my A, which is 2 here. Now, I know if it's reflected if my A is negative. Well, my A here is positive, so I would say there's none. There's no reflection. Part B asked me whether there's a vertical stretch or shrink. Again, I'm looking at my A for this. My A here is 2. Because 2 is greater than 1, I know that I have a vertical stretch. If my A were to be a fraction, then I would have a vertical shrink. C tells me whether I'm moving left or right. So for C, I have to look at my H. My H here is 3. And if you look at the equation here it says x minus h. So we always have to really think about h almost being opposite. So I look at x plus 3 here. So this actually must be a negative 3. Because when I plug it in here, the negative and negative will make this positive. So my h is a negative 3, which means I'm moving 3 to the left. Or in a negative direction. Part D asks me whether I'm moving up or down. So for part D, I need to look at my K. Well, there is no plus anything outside the absolute value, so I can assume that my K is 0. So really I'm not moving up or down, so I would say there's no movement. There's none. And finally, part E says identify the vertex. Well, the vertex is always H, K. And remember, I said that my H is kind of opposite what we see in there. So my H is negative 3. And my K we identified as being 0, since there is no plus K. Okay, next problem is number 9. It says, write an equation for the graph shown below, where the parent function is y equals the absolute value of x. So again, thinking about the general equation, I have y equals a times the absolute value of x minus h plus k. So let's take a look at what I know. I know that my A is a vertical stretch or shrink, and I can almost compare that to slope. So let's figure out if there is a vertical stretch or shrink first for this equation. And I can do that by starting at my vertex and counting my rise over run. So here I'm going up 1 over 1, up 1 over 1. That A is 1 over 1, which is still 1. So really my A is 1. I don't need to include it. there is no vertical stretch or shrink. For my h and my k, well, I know that my vertex is always h comma k. So let's go ahead and write what the vertex is for this absolute value equation. My x goes -1, and then I go up a +2. So I know that my h is -1 and my k is 2. So let's go ahead and write this equation. So the equation is y equals, I don't need to write my a because it's just 1. I have x minus -1. So if I plug in -1 for h, it becomes minus minus, which really becomes +1. And then plus k, which is just +2. So the equation for number 9 is y equals the absolute value of x plus 1 plus 2. Final problem I'll do is number 12, which asks me to graph the absolute value function. So I'm always going to write this general equation down so I can compare everything. I have x minus h plus k. And now, the first thing I want to do to graph is find my vertex. So the vertex is always h comma k. My h in this case, since this is positive, is a -2 because negative would be a positive. And then my k is -3. So I'm going to plot that first. I'm going to go -2 and then up 3. And then what I need to do is look at my a. Well, my a is 1, and I can kind of compare my a to the slope. So from this point, I can go up 1 over 1 and put a point, up 1 over 1 and put a point, up 1 over 1 and put a point, and also do that in the opposite direction. Up 1 over 1, up 1 over 1, up 1 over 1. Finally, I can connect my lines. Some nice arrows at the end of them. And I have graphed this absolute value function. For any questions, see me and Mr. Daniels, and have a fabulous time doing your homework.